Alright guys, in this video we are going to review solving in right triangles. Now before we jump in, let me just kind of give you a big picture of what we're doing here. We are going to move quickly through the different ways we can solve for sides or angles in right triangles. This is not meant to teach you all the new material, this is just meant to review, refresh, hopefully bring this back up to mind. We may look at the way we would set up problems, but we may not solve all the problems we see in this video. Again, this is a quick run through. If you need other help, I would suggest looking at some other videos that go through exactly how to solve individual problems. But in this one, we're just going to go big picture. What are the different ways we can solve things? How do I differentiate between those things? So when we're talking about right triangles, we have a couple tools at our disposal for solving for sides and angles. One that is not listed here is the angle sum theorem, which hopefully we all recognize is if I have a triangle, the angles add up to 180. I felt like that's hopefully something we have down by now, so I did not include it here. You also see we have Pythagorean Theorem. So Pythagorean Theorem is great if I've got a right triangle. These are all assuming right triangles, and I have two of the sides. I can solve for the third side with Pythagorean Theorem. Now, right triangle trig, that's our SOHCAHTOA, and that's really great if I have either two sides. I can solve for one of the angles, or if I have a side and an angle, I could solve for another side. So that gives us a little more flexibility. With the angle sum theorem and the Pythagorean theorem, it's either angle solve for angles, side solve for sides. So this is the first one that really breaks in and lets us solve sides or angles depending on what I have. And then our special right triangles. Now, special right triangles are really just a shortcut between Pythagorean theorem and the right triangle trig stuff. You can actually solve all the problems with just the first two. Even special right triangles you can solve with trig or with Pythagorean theorem. However, special right triangles is a shortcut. It makes it a lot shorter to solve for them. And since we will run into a lot of special right triangles down the road, that is something worth knowing and worth being able to use. All right, so let's just jump in with Pythagorean theorem. Hopefully we recognize this. A squared plus b squared equals c squared. Now the main thing to keep in focus here is that our c squared is always our hypotenuse, which is opposite the 90 degrees. So let's take a look at a setup for one or two of these problems. So in this case, notice my hypotenuse is my x value there. So if I were to set this up, it would be 4 squared plus 6 squared is equal to x squared. Now, let's actually solve this one just a little bit so we can kind of talk about one of the main ways we get this wrong. So in this case, this is 16 plus 36, so that is 52 is equal to x squared. Now, the main place we get this wrong is sometimes we forget to take the square root. Remember, this should, I guess this isn't a great example because the 4 and the 6 don't look to be correct, but it should be bigger than the two smallest sides. But 52 is way too large for that to make sense. So remember, to solve these, we will have to take the square root. Let's look at another Pythagorean theorem example here. So once again, that's my hypotenuse. So that tells me that the 26 is going to be isolated on one side of the variable, or one side of the equation. I'm going to put my variable. Sorry, I didn't mean to put equals there. Let's try that again. I'll put my variable and the 13 on the other side. So how would I go about solving this? Well, you could square everything out and then subtract, or you could subtract first and then square and solve. But you are, instead of adding 13 squared and 26 squared, you're going to need to do 26 squared minus 13 squared and then take the square root of that as well. And once again, we should recognize our answer should be smaller than 26. All right, so that's Pythagorean theorem. Let's look at one application of Pythagorean theorem. So remember, in Pythagorean theorem, if I have the three sides, I can actually determine if a triangle is right, obtuse, or acute. So a right triangle works out the way that you think it should, where a and b are the small sides. If I do a squared plus b squared, it should equal c squared. So for example, Pythagorean triple would be like 3, 4, 5. 3 squared plus 4 squared does equal 5 squared. Now, if I don't have them equal, there's two options. If the two smaller sides squared and added together is larger than the largest one squared, we get an acute triangle. And then the opposite, if the largest one squared is bigger, we get an obtuse triangle. And that hopefully makes sense. If we think about our triangles, right, if this is like an acute triangle, if this side gets sufficiently large enough, okay, it'll become a right triangle. And if it gets too large, it becomes an acute angle. So this idea of the obtuse one having the largest side squared being bigger should hopefully make sense with what's happening inside our triangle. So let's look at one example right here. I've got 6 squared plus 7 squared, and then I'd have 9 squared on the side over here. So what I would do is I would square these and add them. So I'd have 36 plus 49, which is like 85 on this side. 9 squared over here is 81. So I see that my smaller ones are larger. My 2 smaller sides squared and added together is larger than my biggest side squared. And so that means this would be acute in this triangle. Okay, but you could do that for any other triangle. The one other thing you could run into is, remember the 2 small sides also have to add up to be bigger than the biggest side. So say I had sides of 1, 2, and 10. Well, that can't be a triangle if you remember back to your triangle inequalities work. So that would also be a third option or a fourth option. Sometimes there's also a tricky, like, can't be a triangle because the sides, the 2 small sides aren't large enough. So that reviews Pythagorean Theorem. Let's look at SOHCAHTOA and our trig. So remember, SOHCAHTOA is sine, cosine, tangent, where sine is our opposite side over hypotenuse, cosine is our adjacent side over hypotenuse, and tangent is opposite over adjacent. Now, hopefully you have all of this already in your notes, but it's just here to help jog your memory. So we end up notating this as SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. The one thing to remember here is that our sides are chosen based off of the angle that we are talking about. We're talking about this angle right here. So my opposite side is opposite the angle that we are discussing. If I had tangent of y in this case, my opposite side actually would switch down here to where my a is, and my a would be over here. And the hypotenuse will always stay opposite the 90 degrees. So when we're labeling our triangles, just remember that the O side is not necessarily on the right or on the bottom or on the top or something like that. It's opposite to the angle that we're discussing. So let's set up a couple of problems here just to see the setup. And we'll talk through the solving, but we're not going to solve it. Okay? So let's take a look at this one. We'll label our sides. The H side, we should label first, opposite the 90 degrees. I'm talking about this angle of 27, right? So that's my O side, and this is my A side. Now notice what I have in play here. I've got an O and an A. Those are the two I'm discussing. So this means I'm going to use SOHCAHTOA. TOA means I'm using tangent because that's the one that has O and A in it. So I've got tan 27 is equal to my O side over my A side, or x over 14. Before I try to solve these, I would absolutely always set this up right here. If I don't set this up, I'm going to get some of them wrong because I don't get the, I don't end up knowing which way to solve, whether I multiply or divide. All right, x is on top in this case, so to solve for that, I'm going to multiply both sides by 14. So I would end up plugging 14 tan 27 into my calculator. Now remember, with your calculator, you're going to get the wrong answers if your calculator is not in degree mode. So you can hit the mode button at the top of your calculator, or if you're in Desmos, you can hit the little setting tool in the top right corner to double check if it's in degrees or radians. And in Desmos, you'll hit the little settings tool, and at the bottom there's a little toggle that says degrees or radians. Make sure that degrees is the one that's chosen there. All right, so you could solve this on your own, and I will leave that up to you if you want to do that. Let's look at this next setup here. So again, I'm going to label my sides. That's my H side. This one is my O side. This one is my A side. I have A and H. That means this is going to be cosine. So I do cosine of 58 is equal to my A side, 26, over my H side, x. Now notice in this case, x is on the bottom. I can't just multiply both sides by 26. That's where a lot of people go wrong. They just say, oh, it's always the side times the trig ratio of the angle. Well, no, in this case, we would do 26 divided by cosine of 58. If I solve this out for x, it would end up looking like this. All right? But if I solve that out, that's clearly 26 divided by cosine of 58, not times. So we do want to be careful, and I could solve that out as well. And again, just like Pythagorean theorem, our answer should make sense. If I do 26 cosine 58, this hypotenuse ends up being smaller than 26, which should be a red flag that that's not the right answer. All right, let's look at this last one here for SOHCAHTOA stuff. Notice we label our sides, O, H, and A, and this O is opposite this angle. That's the one we're discussing here. So I've got O and A. This is going to be another tangent. Okay, so I'm going to set this up. Quick tip: if it's inside in the triangle, if it's inside the triangle, it's going inside the parentheses. So that's an easy way to remember that. And I get 16/7. Now notice, in this case, I'm not multiplying or dividing things to the tangent in order to get the x by itself. What I'm going to do is the tan inverse. So I would do tan inverse of both sides, and this is what I'd end up plugging into my calculator. Now, if you're on a calculator, you can hit second tangent, will get you the tan inverse. Or if you are on Desmos, what you're going to do is go down to the little keyboard in the bottom left corner, and then about 2/3 of the way to the right, there should be a little thing that says functions. Click on that, and you should find your sine, cosine, and tangent inverses. That's where you'd find those. So that's a quick review of SOHCAHTOA. Let's look lastly at some special right triangles. So remember, these are shortcuts, but they're very fast shortcuts, and we use them a lot, so they are worth remembering. So there's lots of different ways to solve special right triangles. The way that works the best in my brain is to think about this in terms of relationships. So the side and the hypotenuse in a 45, 45, 90 has a relationship of √2. And if I'm multiplying, or I'm sorry, if it's getting bigger, I'm going to multiply by √2. But if I'm going, say, from the hypotenuse, which is the biggest, to a leg, which is smaller, I'm going to divide by √2. Okay? And always make sure you're rationalizing your radicals. Again, that's another thing you can check out in a different video if you need to. Now notice over here, I would run everything through my shortest side, the side opposite the 30 degrees. Notice here the relationship is √3. If it's getting bigger, I'm multiplying. If it's getting smaller, I'm dividing. And over here, my relationship is 2. I'm multiplying by 2 to the hypotenuse or dividing by 2 if I'm going to the shortest leg. So, I know that was a light speed review here, but we just want to hit all the different topics, keep the video somewhat short, so hopefully this is helpful. This is not really a video to learn how to do the things, but if you see something you're like, oh yeah, I remember that, but I don't quite remember how to do that, I would encourage you to spend some time looking up some other videos on that topic. As always, if you have any questions, feel free to reach out to me.